curriculum. So we have integrated STEAM into the curriculum. So what students are required to do is demonstrate their understanding of concepts through STEAM. So which means that they would have to actually go to the STEAM lab and either create a product or create some kind of anything. For example, let's say they were learning about the digestive system, right? So they create the entire model of the digestive system and try to get it into a working model using the 3D printer, printing different parts, putting it up, trying to explain how it actually works. A lot of working prototypes or proof of concept is actually created by the students. Now, what I found is the students of today are much more technologically savvy. They know how to use AI for coding, right? They're very smart compared to the traditional teachers that all of us are. So yes, it requires upskilling, which teachers probably will do now or will be forced to do through their students as well. So the role, like Dr. Stroop was talking about, the role of the traditional teacher, or even Mr. Brent, he was saying that earlier he used to just teach, knowledge was given, and he was testing for that knowledge given, but he didn't really know whether the students were able to apply that knowledge. So we are looking at it more from an application perspective when we send the student into the lab saying that, okay, go and create something, use your creativity, use whatever resources are available, use AI even if you have to get ideas, use the 3D printer, do video content making, do some kind of chart only if it is, or a cardboard model, doesn't matter, but do something to demonstrate that you have actually understood the concept. So now what is our biggest challenge is actually time, because we are working on a structured kind of weekly, you have so many periods, so many classes are given to different subjects. We are saying interdisciplinary connections, try to find those, connect computer science with language, for instance, show how Macbeth, the concept of the character of Macbeth might actually be, demonstrated through concepts from computer science. So students are at a slightly higher level, I think, than what all of us have been discussing over here today. But the challenge becomes then time. Students do not have enough time in the STEAM lab, so much so that our students who live on campus are actually willing to work over the weekends in the STEAM lab. So our biggest challenge is time. And if you're really looking at problem-based learning from the real world perspective, and we do a lot of design thinking as well in the school. Right. So if they have to actually go out to the field and understand what is the user's concern or what is it that the user needs, help with or something like that, there again, we have a challenge with, these field visits, then coming back, collecting user data, collecting secondary data. So, there's a lot of things that students are really, really capable of, but it would all depend on, how we as teachers probably guide them through that process. And because of the way things are being done, again, I would take a word that Dr. Stroop used, which is agency. We do see a lot of agency coming from the students' end.
Right. I think it looks like we need a lot more time to explore all the opportunities and possibilities what we are discussing right now. And probably, the next conclave, I think Sudhanshu and, the entire team of ISF, we can actually focus more towards discussing all these points because beautiful ideas have come up and the real-time challenges which we are talking today. So thank you so much, Dr. Savita, as well for your thoughts. To sum up, we understand that there are a lot of challenges to implement STEAM and making it hands-on and making it